um, identify the form of the model. So this model is parametrics. We expect the solution will also be in parametrics. So the types of models, the type model is linear. So we can use the matrix approach to solve for the model, to solve for the endogenous. Okay, what else? So, well, basically, you can read it yourself here. So the fact is that now, yeah, the next with considering step is to reduce, yeah, the size of the model. Yeah, simplifies as as simple as we can. So what we can do is to eliminating some of the variables. How do we eliminate? We eliminate it through substitution. We substitute equation 3, 4, and 5 into equation number 1. So we basically we end up with 1 prime new kind of equation number one. Okay, and then we have equation number 2. So what we can do is substitute. We substitute equation 3 in equation number 2, whereas equation number 4 and 5 we substitute in equation number 1. So we end up with equation 1 prime and 2 prime as shown here. Can you guys see the slides clearly? Okay, good. So well, basically, you realize that in the beginning we have 5 equation models. Yeah, oh, of course. Yeah, I forgot to mention. We also need to, before we start reducing the system, what we can do is basically do the checking, whether or not the necessary conditions, for the solutions, is fulfilled or not. Meaning we compare number of equation and number of endogenous. In fact, we see there are more equations than number of endogenous. So that shows that the system is consistent. Yeah, we expect there will be a solutions. Okay, only then we start to reduce it, make it smaller. Yeah, so we end up with step number 2 here is clear. Yeah, we have now, instead of having 5 equation system, we end up with 2 equation system. Okay, this 2 equation system allow us now to continue preparing for the what do you call it, matrix forms, forming the system into matrix. What do you call it, notations. What we need to do is the matrix notation, the system written in matrix notation is Y. This is AX equal to B. So what we need to do is basically we need to rearrange the system so that later we can continue forming the pre-arranged system into matrix form. How do we arrange it? Basically, we will bring all the endogenous variable together with, if there is any coefficient with the variables endogenous, so we'll bring it to the left-hand side of the equal sign while keeping the constant, parameter, together with the value of the exogenous variable on the right-hand side of the equal sign. Okay, so we do it. Okay, so once we rearrange it, this is what we have. The principle of arrangement is clear. By bringing anything which got to do with endogenous variables on the left-hand side of the equal sign, and keep the values, exogenous values together with the constant parameter on the right-hand side of the equal sign. Okay, this is what we have. Okay, and then next, we start to, what do you call it, filling in the so-called the coefficient matrix A. Okay, since we have A, we have the vector X. We also have the constant vector, vector of constant. And so we our earlier suggestion in the last class, we are saying that start to fill in the element for vector of endogenous first, because it will set the tone, set the standard of how we arrange the coefficient matrix. We begin with, after we actually rearrange the system in AX equal to, fill in the corresponding, what is corresponding X, the vector X first, before what we call filling the matrix A and the vector of constant B. Okay, so we have X here, we have Y and C as our endogenous, and then we start to fill in the members of the matrix A, which the element from matrix A is in fact the coefficient for the endogenous variables. Meaning, if we were to expand back the, what do you call it, the element of matrix A, and multiply it by the element of vector X, we'll certainly get back to the left-hand side of the equal sign. Whereas on the right-hand side of the equal sign is nothing but all the constant parameter together with the value of exogenous. Okay? And then it's a good practice to basically write down the dimension of each of the X vector, the A matrix, as well as the vector of B. Okay, so we have 2 by 1 for vector X, and of course conformability, conformability, and also the fact that later, whatever, we are with this understanding that later we need to compute. Among the things is, regardless of which approach that we use, in the sense that which matrix approach, we need to compute the determinant for the matrix A. So we also did mention the questions of computing determinant of a matrix, implies or requires that the matrix must be square matrix. The questions of determinant only relevant for square matrix. So that means, in order for us to make sure that A and X are conformable in the sense of matrix multiplication, and also we know A must be square, so then A definitely must be 2 by 2. Okay, 2 by 2, since why? We have the vector of endogenous 2 by 1. Remember, the what do you call it? The tips to have 2 matrices considered conformable in the sense of matrix multiplications require that the lead matrix, the columns of the lead matrix must be equal to the row of the like matrix. Okay, so well, basically this is what we have, and now what we need to do, well, basically at this stage, we can pick up which approach, either using the Cramer's formula to solve for the endogenous, or we can use the what we call it inversion techniques. So both, if we do it correctly, so will lead you to the same answer. for the endogenous variables. Now, suppose now we are using the, we call it inversion techniques, require us to what we call to generate the A inversion. In order for us to compute the A inversion matrix, A is a matrix. Inversion of matrix also will give us a matrix called an inversion matrix, of A. In order for us to compute the inversion matrix of A, we need two pieces of information. First one is to compute the determinants for matrix A. Determinant is always a scalar. It's always a scalar. Scalar means number, not collections of numbers. It is just a number. Okay, remember? Meaning scalar operations involving scalar operations involving matrices. So there are certain rules in terms of algebraic operation. Operations algebraically. How we operate scalars and how we operate what we call it matrices. Okay, so you need to be you need to know this. There are the do's and don'ts. Okay, so I leave it to you to think about that. I just mentioned. Okay, now having computed the determinants for matrix A 2 by 2, so we can just compute it using the normal, what do you call it? Techniques that we learn again and again. So we have its determinant is 1 minus B, and then we start to compute the adjoint. The adjoint for 2 by 2 is simple. Then we just switch the position. A, B, C, D become D, A, D, take the place of A, and at the same time, the place of D taken by A, and then put a negative sign in front of the B and C. Okay, so we have here, so now we have adjoint is 1, 1, because we have actually A and B is the same. Initially, the position of A and B is, and the value of it is 1, 1, so it doesn't change anything. So the negative sign, we again put in negative, become positive, negative B become, at the end, become positive B. Okay, so this is the adjoint matrix. So now what we need to do is, we can use the information, plug in here. We know the formula to solve for the X, the unknown vector, is A inversion. That's what we did just now, preparing the information for the A inversion. Okay, we get matrix, meaning 1 minus determinant of A times adjoint matrix. So this will basically give us a matrix called inversion matrix. 1 minus B, 1 over 1 minus B times a matrix 2 by 2, adjoint matrix will give us an inversion matrix, which is a matrix of 1 over 1 minus B for the A11. A12 is also 1 over 1 minus B. For A21 is 1 also B over 1 minus B. For the A22 is 1 over 1 minus B. Okay, we have not yet finished. We need to multiply back with the vector of constant. Okay, so, and then by doing so, we'll end up with the solutions for the endogenous vector. Okay, endogenous vector. This is basically the Y bar, and this is basically C bar. Okay, so the neat things about using matrix, basically we can get it at the same time, the solutions, and it is, well, it's neatly, what do you call it, written, neatly presented. That is the beauty of, among other things, the beauty of presenting it in the forms of matrices. So Well, basically, once we have the what you call the endogenous, yeah, we may want to reconfirm value of this so-called endogenous using an alternative matrix approach using the Kramers formula. Okay, just that what you need to do, the Kramers formula you need to generate. So first, you need to form the A1, label it a new matrix, A2, a new matrix, two additional matrices beside the original A. Okay, from the new two matrices A1, you compute its determinant. Together with A2, you compute its determinant. And so once you have the value, so you just put in the formula, basically the fractions of two determinants, the ratios of two determinants. Okay, make sure you the denominator and numerator. And for the numerator is basically the new determinant for which generated from a new matrices. Okay, whereas the denominator one is basically the matrix of A. Okay, so well, basically it. Of course, here we have only two endogenous, so we have we need to generate two additional A matrices, A1 and A2. Okay, no such thing as A3. Okay, because we have only two endogenous. Okay, is that clear, everybody? Is that clear, everybody? Okay, you can verify yourself, work it on your own. Okay. Okay, now let us consider another exercise. This exercise also taken from the previous topic we have seen previously. Yeah, this model. Again, income determination model with different with different variants. Okay. Well, now we have what? We have T previously in the what called in the last model we have seen T is exogenous, but now T become endogenous. Okay, T become endogenous. Now again, the steps involved, applies here. Get to know the model among the things endogenous and exogenous. Okay, and then check for the form of the model, and then type of the model, and then pick up. Since it's linear, you may want to use now using matrix approach. Okay, and of course here you have three endogenous, and then check also the what you call it, the number of equations. We have four number of equations. We have, it's not what do you call it, three endogenous, should be four endogenous here. We also have YD here. Okay, since YD, you can solve using matrix. Matrix approach as well. But my suggestion, be smart. Okay, since equation number 4 is rather what do you call it? Definitional equation. It is a definition. Meaning, why this possible is the difference between nominal income and the tax. Okay, so what you can do is basically if you want to reduce the so-called what do you call it, the burdensome of dealing with 4x4 matrices. Okay, since we have 4 unknowns here, 4 endogenous, what you can do is, equation number 4 is rather definitional, so you do not include it in the beginning as our endogenous while forming the so-called the vector of endogenous. What we can do is basically, once we solve the value of y and t, we get the equilibrium value for y and t. Okay. So we later substitute using the substitutions methods, yeah, to solve for the y d equilibrium. Okay, is that clear, everybody? That is smart way of doing it, because you will be able to move away from the 4x4 matrix, solving the 4x4 matrix. Okay, that is things that you need to consider. Whenever you are asked to solve your matrix, work smartly. So make sure you are able to handle it confidently. Okay, is that clear, everybody? Is that clear, everybody? Okay. Is there any question? So far, so good. Understand what I'm trying to say? Here, what I get, let me repeat myself. Okay. Okay. It's clear. I think it's clear. Okay. We have 4 endogenous. Meaning, we need to be smart. Yeah. When we want to solve using matrix, we also understand, solving the 4x4 matrices, is quite a big task to handle. Okay, it's not something like impossible. No, it's possible, but it will take a lot of times, especially when we are dealing with parameters. If we are dealing with numbers, it is manageable, even though it's, despite the fact it's going to be quite a long task. Okay, but now we are dealing with parametrics, so the best way of doing it, we reduce the size, the principle of making it smaller. So by doing it, making it smaller, make it more manageable. Later, the remaining endogenous will be handled through substitution later. Okay. So what you can do is basically equation number 4, we remove yd from equation number 2 by substituting equation 4 in equation number 2. So meaning yd disappear. Okay, yd disappear. So now we can start forming from here 3 by 3 by rearrange the system. We reduce 3 equations, becoming 4 from 4 equation becoming 3 equation system. Okay. However, keep in mind the yd remain endogenous. Just that we do not choose to solve it using simultaneously using matrix approach, because it's quite a big things to handle. Especially we are dealing with parametrics model. So smart way of doing it is through elimination, removing the yd temporarily. The fact that it remain endogenous is clear. We need to come back later once we have everything. We have solve the y, c, and t. Later we can come back using substitutions approach. We'll get what is y, d. Is that clear, everybody? Is that clear? Okay. Let me check how many of you are here. Okay, we still have, we're supposed to have 87. Now we have only 61. Yeah. Got 26 person missing. Okay. I don't know what excuse they're going to give. Yeah. Okay. So here also in this exercise also it's given number. You can basically substitute the number in all the parameters. So you'll get the equation now being switched to the numerical form. Okay, if you were to substitute all the given values here, numerical values, back into the original equations, basically you will now transform the parametrics version into numerical version. You may want to work then on the what do you call it, using the numerical models. You see then what you will get using matrix approach as well. Okay, so that is it. So I leave it to you to work out on your own. Okay, exercise number 2 also. Now you have seen the similar version in topic number 1, where now we do not have T as endogenous or as variables. Okay, we have instead, we have G. Yeah, and with G here, yeah, becomes endogenous now. Okay, again, you may want to continue, yeah, get to know the model. Yeah, as usual, there are a couple of things when we are saying get to know the model. Among the things, identifying types of variables, okay, and then the forms of the model, the types of the model, and then pick up the since it is linear, so you may want to use the matrix approach. You can solve using both what we call it, elimination. What we call it, inversion techniques or Cramer's law. Both will give you the same answer. Okay, so there are a couple more exercises for you. You can see that, exercise number 3 and exercise number 4. Okay, so I leave it to you. I believe some of you have worked out, because this exercise, I just took it exactly or directly from the topic number 1. The difference is that the methods used. Okay, so I think we finished talking about the macroeconomic model or Keynes model or income determination model. Any questions so far? Any question? Okay, I presume no questions. So let me continue to the next model. Let me see the next model. Okay. Can you guys see what I'm sharing here? Okay, I'm sharing basically second part of the topic. Okay, so I divide the topic into 2 parts. Yeah, the first part consists of what we call it, general model, market model, and the macro income determination model. Both of the model we use the matrix approach. Now let us continue with 2 more models. These 2 more models, basically a new model. We have not touched any model while discussing the methods of elimination. Topic number 1. This model did not being introduced. Okay, well, basically, in short, let me introduce briefly the what we call it, the good and money market model. Okay, the good and money market model is basically an extension to macroeconomic model. We have seen the income determination model shortly or just now. Okay, so well, in theory of macro, there is a discussion, a topic being what we call it, a topic on the ISLM, which the IS stands for the investment and savings, which basically represent the I would call it good market, and the LM, well, stand for liquidity market, or, some talk about the money market or bond market, okay, which represent these two markets, is another way of, what do you call it, understanding the economy at the macro level, okay, by what? By breaking the economy at the domestic level into basically two market, called the goods market and money markets. Okay. So let us, without spending too much talking about on the theory of the this ISLM, let us now see how this mathematically ISLM model presented. Okay. Before we consider this what do you call it, numerical version of the ISLM, this example, mind you, for those who, I think quite a number of you are taking macroeconomics, and a few of you have taken it, macro. So, well, basically the IS, as I said, stand for investment saving, which represent the good market in equilibrium. Good market in equilibrium. Remember the word equilibrium. LM, which actually represent the money market equilibrium. The money demand and money supply. Okay. Consider, well, money as kind of commodity called money. Money. So there are demand for money and supply. For money, demand for money, supply of money. And so, of course, it is a market for this basically a commodity called money. So at the end, it will settle at what we call equilibrium money market domestically. Okay. If later, of course, in the macroeconomics, we will also be introduced to what we call the open version of the macroeconomic model. The ISLM and BOP, balance of payment, or BP, balance payment, being included. So I just here, rather than talk about the balance of payment, which in fact allow the foreign sector to the impact of the global economy on the domestic economy to be in the picture, I just ignore it and leave it to the topic for you to learn in macroeconomics, the BP and balance of payments. Okay. I just want to show you the brief version. Of course, this is domestic version. When we talk about domestic version, it means like, it means what we have considered only, Y equal to C plus I plus G, no export, no imports. Because if we were to consider the export plus import, so forth, we will need to consider the balance of payments, to represent, we call it BP, relationship. Okay, well, basically, having said that, so now suppose we are given numerical version to ISLM. Remember, IS basically represent what? Good market equilibrium, not just good market, but a good market when it is in equilibrium. When it happens, we call it in short IS. So similarly, when we have money market equilibrium, so we in short we call it the LM. Okay. So these two equations you can see here, equation number 1, equation number 2. The IS, both IS and LM, if you were to consider, look carefully, there are two variables here. One is Y, another one is little I. Y stand for, well, Y stand for income, okay? Income, I stand for interest rate, okay? Income, national income, I stand for the interest rate. And this variable, both of them appear in, yeah, in IS and LM. So you need to be able to differentiate between, yeah, IS and LM, yeah, yeah, since both involve relationship between Y and I. Y and I, okay, Y and little I, income and interest rate, both. How do you differentiate it? The way we differentiate is basically to see whether the relationship between Y and I is positive or negative. That will set what we call parameter or a demarcation line between IS and LM. Okay, when we have the relationship between Y and little I, Y represent income and I interest rate. Okay, and then if the relationship between is positive, then that has to be the LM. When it is negative, it has to be the RS. Okay, so I don't know if let me see if I can not so friendly here. Okay, whiteboard. Let me try the whiteboard here, if I can. No, cannot. It's not that friendly. Okay, that's okay. Okay, I cannot use the. Okay, that's okay. Yeah, later when we meet, we call it face to face. Well, I will basically, yeah, what I call it, sketch it on the whiteboard. Okay, well, basically you can see here, this is IS. Can you see here? This is IS. Y set IS. Remember, yeah, negative relationship between Y and I. How do you know it's negative relationship? We need to represent it in terms of Y is a function of I. Okay, Y is function of, meaning you need to bring the I to the right hand side of the equation side, equal sign. You'll see the negative sign of I. I become negative. Similarly, yeah, Y LM is said to be positive relationship. You need to bring the I, yeah, to the right hand side of equation sign, equal sign. So you have Y is a function of I again, but the relationship between Y and I, yeah, is positive. If you bring this negative 250i to the right hand side, you have positive 250 times I. Okay, that's why that differentiate, yeah, what we call it, between the ISLM. Just like relationship between quantity demanded, the Q and P. Q, quantity, is a function of P, right? How you differentiate, yeah, which one is, which equation represent demand, which equation represent supply? Yeah. When the relationship between Q and P is negative, that must be demand representation. When Yeah, instead, if you have a positive relationship between Q and P, that indicates or shows the supply relationship. Very much similar to ISLM, just that we do not have Q and D relationship. We have Y and I relationship. Little I stand for one, interest rate. Y stand for income. Relationship between income and interest rate. When it is positive, Y is related to I positively, so it becomes the LM. So the curve, if we were to sketch it, will be positive slope. Yeah, with the Y axis become Y and the I axis. We can put the Y axis is I, the X axis is Y. The relationship between Y and I and Y is, well, basically positive, should be in the LM curve. If the relationship between Y and I and Y is negative, so we have basically the downward sloping IS curve. Okay, so I hope you can imagine that. Okay, now, so this, what we call it, we want to solve using matrix approach. Yeah, we want to solve using matrix approach here. So what we need to do, knowing the endogenous, as usual, the form of the, what we call model, the type of the model, since we want to use, what we call matrix approach, the model must be linear. So in fact, it's linear. So what we need to do next is what? Check for the necessary conditions for the solution. We have two unknowns, two endogenous Y and I, and two equations. So the requirements or the necessary conditions has been fulfilled. So there is a solution, we can solve it. And then what else? What else? Basically, we need to rearrange the system if the system has not yet in that so-called in a readily form. Okay. However, when we look at this equation number 2 and equation 1 and 2 is already presented in the basically readily form. We can basically change it into the matrix notation AX equal to B form. Okay, and then fill in the endogenous vector first. Okay, the X vector, which is Y and I, and next fill in the matrix of coefficient, the A matrix. We have 0.4 and 150. Another one is 0.9 and 250, minus 250. Okay, and the vector V is basically 209, and another one is 35. So then we can use the matrix approach, either substitution, either what we call it, matrix of inversion, or using Cramer's rule. So this is basically it. Workout examples for you. So having formed the basically the A, the X, and the B, and then we can just solve using either approach, Cramer's or inversion techniques. So already solved for you. You can take your time to later work out on your own. Okay. And now there is an example for you, workout example, I believe. So again, you can see here, this is a version where it's not like the one we just saw. Okay. The above example we just saw is basically what we call it, the simplified version of ISLM, already converted into ISLM form. Okay, this is the raw version of ISLM, where you are given some what we call it, equations, which are meant to form the IS, and some equation meant for the LM. You need to know which which equation represent the LM, which equation represent the IS. Okay, IS stand for one, IS stand for investment saving. In short, it is money is good market. So you need to be able to identify among many equations here listed here. In fact, it's not being labeled. Yeah, you may want to label it, and then not only label, later you need to pick up. Yeah, after label it, which equation consists of which equation would be relevant to IS, which equation are relevant for the LM. Okay, since the IS stands for good market, so you'll see the C equation, the I equations, should be the Y equation, should be included while solving for the IS. Okay, whereas the anything MT, MW, MD, MS are all equations relevant for DLM. Remember IS, the good market equilibrium, LM, money market equilibrium. So when I said it's given in the raw form means the equilibrium has not yet been solved. Okay, not yet been solved. You need to solve for the equilibrium of each of the market. The equilibrium will represent either the IS or the LM. Okay, so is that clear, everybody? Is that clear, everybody? Hello? Okay, you have many equations here. You have C equation, you have I equations, you have MT equation, you have MW equation, you have Y equation here, you have MD equation, you have MS equation. Label it. Label it accordingly. And then from then you will need to pick which are relevant to solve for the IS, meaning to solve for the equilibrium. That equilibrium is meant for the IS. And which equation you need to basically to solve for the LM. Once you have solved for the IS, the equilibrium equation for the IS and the equilibrium equation for the LM, you put together. Okay. What you have seen previously here is basically equilibrium equation. In this example here, I've given you the equilibrium equation, meaning there is a story behind it. This is already what we call it the clean version. You get the equilibrium, which represent the IS equilibrium equation represent the LM. The raw version is basically quite a number of equations. Okay. From this equation, again, you need to identify which is relevant or which equations are relevant for you to generate the IS equation, and which are the equations relevant for you to generate the LM. Okay, so that is basically let me move below. You see here, after picking up the correct equations, okay, you'll be able to basically generate here both the IS, LM. Substitute C into I into substitute C and I into Y equations, like we did previously when we talked about income determination model. So we'll get basically at the end we simplify, we'll get the at the end Y and I relationship, income and interest, little I. Okay, this is what we have here. This is all basically we use the Y equal to C plus I. The C we substitute what is C, and I also we substitute what is I. And so we see basically the C gone, I gone. Remember, we are not interested at this point to solve for the C and I. We're interested the endogenous in this model, in the ISL model, are Y and little I. The endogenous in the model, the ISLM model is Y, capital Y and little I. Okay. And then again, of course, in the whole model, in the original model, yeah, you know the C and capital I, Y are all endogenous. We have MT, MD, yeah, MW, MD are all endogenous. Just that MS is exogenous. Okay. Once you solve for Y and I, you can solve easily for the remaining endogenous. Okay. For the remaining endogenous. Okay, you solve for the Y and little I. Yeah, you solve it. Yeah, solve it using matrix approach. Once you get Y equilibrium and little I equilibrium, you go back and substitute into the original equation. Accordingly, you'll get the remaining endogenous. Okay, is that clear, everybody? Is that clear, everybody? Okay, now same goes to the we call it the LM, yeah, equations, which represent the money market equilibrium. You see here, you rearrange it so that later, this is not arranged as yet. You see, equation 1, equation 2, not readily arranged, yeah, in the forms readily in the matrix, yeah, equation, in the matrix form, readily to form a matrix. Yeah, so what you need to do to bring whatever relevant to the left, whatever relevant to the right. Okay, by rearranging it, you'll see now. Yeah, we have this so-called version 1' and 2'. Okay, that is IS and LM. Okay, nothing relationship between Y and I, both. Just that one is positive, one is negative. Remember, don't get confused. Yeah, the IS is basically relationship between Y and I. Eh? The relationship is negative. Don't get confused, yeah, because when we place it together, of course, the negative become positive here. Okay. However, the relationship between Y and I is negative for IS. Yeah. The sign here because you move from right to left. Why you move from right to left? Because you want to form matrix approach. Yeah. You want to basically form the matrix form. Okay. For the system, yeah, become represented in the matrix form. That's why, yeah, you bring or you bring the what we call it, the I to the left hand side equation, equal signs. So don't get confused. Yeah, the relationship between Y and I for S is still negative, whereas the relationship between Y and I for the LM is positive. How do you know it's positive? Some fail to see it. Here is negative. How come you're saying it's positive relationship? Well, to see it's positive, you need to bring, Y is a function of I, meaning Y is on the left, I should be on the right. And then you see the relationship positive or negative. Is that clear, everybody? Is that clear, everybody? Okay, clear? Okay. So, well, basically here you can later solve it, yeah, using a matrix approach. Okay. Okay, you can both use both methods, Cramer's or what you call it, the inversion techniques. This is another example exercise for you, not given in raw form. You need to know which is which to form the IS, which is which equations relevant to form the LM. Meaning all these equations are in raw form. Remember the definition of IS, LM, yeah? Equation that represent equilibrium in each of the market. Okay, as represent equilibrium in good market, meaning the equation here is not equilibrium. You need to solve for the equilibrium. So what? Need to pick up the correct equation so that you can solve, yeah, for both the IS and LM. Okay, is that clear? I repeat myself quite a couple of times, so I hope it's become clearer. Okay, so you can, yeah, take time to work out on your own. Pick quite a number. Okay, well, the last model is basically the input-output model. Input-output model. Okay, so for the input output model, I'll just introduce briefly. So you go back and study on your own. Yeah, after the long holiday, we'll come back. I will assist you to elaborate further. Well, basically, for the input output, let me explain briefly. Well, basically, we consider the activity in an economy. Forget about the two market model we have seen just now, the ISLM. Now, completely, now let now consider activities and interactions among firms or industries or sector in an economy, depending what level you want to talk about, sector level, sectoral level, or industry level, or firms level. Yeah, that is basically use of input output. Yeah, the use is basically for planning purposes. Okay, for planning, it provide the hands-on information for the planner, for the government, for policy making purposes. Okay, interactions. Let us consider what we call it industry or firms. Yeah, in this setup, we assume there exists a relationship among firms, among firms, meaning my firm, buy inputs for my products. Okay, inputs for my products. I produce product called product A, but in order for me to produce that product, I require inputs. Beside labor, beside capital, material inputs. So that material input I do not produce myself conceptually. Of course, I also in this setup allow, if I were to conceive part of what I produce as my input, can also. But let it be in more general form, meaning I produce types of good, I use input, get input, basically produced by other firms. Okay, so I buy it from them. Okay, there exists relationship, between me and other firms. Of course, when I produce a good, there are firms. The firms also require my output, my production, my goods, my products as part of basically their input to produce their own products. Okay, that is basically it. Assumptions like that. If that is basically it, we can some mathematically, we can write it in this forms. If A, Ij is technical coefficient which signifies value of input requires to produce 1 ringgit worth of product J, okay, then the total demand for product I can be expressed as. Meaning, what matters is, for a nation, they want to know how much, the nation needs for that particular products. Example, rice, for example. We of course, as a nation, produce rice, but it's only probably it's only meet 30% of the 100%. We took the 70% come from abroad. We import. Okay, imagine other products locally made. Okay, locally made. Okay, relies on many other firms or industries. Okay, so that relation, the total demand of that products, particular products, basically, can be mathematically presented as like this: A1I X1 plus I2, X2 plus AIN XM plus BI. Okay, that is only for single types of products, okay, or produce, depending, okay, products. So, well, basically, I1 stand for if I were to consume part of what I produce. Is permissible in this setup. Meaning, if I do not produce, I completely sell my product. I don't consume back. Any percentage of what I produce. So that would be AI1 becomes 0. Okay. The fact is that the total coefficient AI1, AI2 until AIN basically should end up with what? Equal to 1. Okay, equal to 1. Cannot be greater than 1. Okay, that is basic part of the assumptions underlies this setup. Okay, so then meaning given that now we in an economy we do not have only one type of products or firms produce their products. We have hundreds and thousands of firms involved, so that we can have a vector of a products. Represent x1 for types 1 until types n. It can be presented in the forms of vector of x. Similarly, the coefficient, the share of that particular products by other firms in an economy, the coefficient can also be presented in, we call it the A matrix. This certainly, later we are talking about this input-output model, in when discussing about matrix approach. That means the A coefficient must be what? Must be square matrix, whatever what you call it, whatever the dimension of A is. Okay. B, what B stand for? B is nothing but we talk about the demand also not only from we call it from industries. Industry means I buy your products not for my own final consumption, but I use it as an input to produce my own products. That's what industrial consumptions. Other firms buy our products for their own needs, for their own as an input for their own products. Okay. B represent what we call the household demand, meaning the demand of a product from an industry, but it is basically for their own individual use, household use. Okay, meaning it's not meant to produce and what do you call it, a new products. No, we consume it for good. We call it consume for good. Household consume a product for good. Industry consume, firms consume for products as an input for their own productions. Okay, is that clear, everybody? Is that clear, everybody? Is that clear, everybody? Okay, so if we can represent it using basically matrix notations, knowing that X stands for vectors of products of several firms, A represents coefficient, a share, a dollar share, we call it technical coefficient matrix. B is basically the final demand, of firms, what do you call it? Firms products or firms one's product, firm one's product until firm n's products. Okay, then we can basically use matrix. And our intention is again to solve for the, remember we want to compute how much a nation should produce, meaning so that each of the industry which produce product, label product 1, product 2 until product n will not have what we call it excess or surplus or shortage. Minimize the shortage and surpluses. Okay, so our intention to solve for the X how do we basically solve for x? Again, what we can do is basically we can do some algebraic manipulations to this system of equations, and then by observing the fact that these equations represent all in a matrix notation, so we need to observe the do's and don'ts while operating matrices. So we have, these basically equations. This, please make a correction. This is not one, yeah. This is I, capital I, which represent matrix of identity. Yeah, this is not one. A correction, typo here should be identity I, capital I, which represent matrix of identity, matrix. So the solutions conceptually, the X bar represents solutions is basically an inversion of the capital I minus A, yeah, close bracket, inversion. Inversion of I minus A matrices. What is actually I minus A matrix? Also known as Leontief matrix. Okay, also known as Leontief matrix. Okay, and again, we multiply by the vector of B later. Okay, so that is basically it in conceptually. Okay, what is I minus A? I minus, yeah, you know identity matrix. Identity matrix follows the basically the A. Okay, if A square matrix, then I also identity matrix. I, yeah, I matrix minus A. So this is how, yeah, technically is written. 1 minus A11 become minus A12 minus A13. Yeah, if we assume we have only 3 sector, yeah, or 3 firm economy or 3 sector economy, meaning we have sector 1 represented by X1, X2, and X3. Okay, these are basically A11. All the rest, the diagonal element, you have 1 minus. Okay, diagonal element, principal element. 1 minus A11, 1 minus A22, 1 minus A33. The rest is negative. In front, negative. Because why? Because, yeah, this is a details form of the identity matrix minus A. Okay, and then you invert it. Okay, and then you will get basically, of course, you need to basically invert matrix using, yeah, matrix of inversion, adjoint matrix, so on and so forth. This is an example, numerical example. You may want to study slowly and see, yeah, how, yeah, it is solved. Okay, it's very much similar to the previous, yeah, what we call methods. We use the same methods, inversion techniques, just that, yeah, you need to be very careful how, yeah, I, the capital I minus A. And then this is an example to show. This is capital I, yeah? Please correct. Yeah? This is written, this is number 1. It's not number 1, it should be capital I. The capital I represents identity matrix. You can see here identity matrix. Yeah, how you generate capital I minus A, how you generate the Leontief matrix. Then you invert it. Okay, you need to invert it. How you, basically the principle of inversion, similarly, you need to compute the determinants and find the adjoint matrix to get the inversion matrix. Okay, so I think, yeah, that is all, yeah, I want to share with you tonight. So any questions before, yeah, I share the QR code for those who have yet to, yeah, scan? Many, yeah, have not, yeah, what do you call it, yeah, attended our meeting tonight. Only 64. Okay, so I'm sharing. Is there any question? Question? Okay, no questions. So I'm sharing. Allow me to share again the QR code. Let me share the QR code for the let me see the QR code for group A first. Let me see.